Okay, so this is the November 2014 non-calculator GCSE higher tier paper, and we're looking at how to get up to a grade C. We're not looking at every single question here. So grade C on this paper was 28 marks. For grade B it was 46 marks. And I've just been through the paper with the stuff that we've done with my class this year, just the things that everybody's done all together in the lessons. There's 42 marks on this paper, and if you've done a few extra bits and bobs as well, there's at least another 24 marks. In fact, there's a few more than that. So you'll notice that actually there's quite a lot of marks here. If you watched any of the other videos that I've done, we don't normally have quite that much, but having had a quick look through the paper, I think what we're finding is that there's a lot of marks that we can do, but they're not always the easiest questions on the topics that we've got. So let's see how we go. I should say as well, by the way, apologies if you're waiting for this video. You can probably hear I've got a bit of a sore throat, so I was hoping that that would go away, but you're just going to have to put up with my croaking through this one, I'm afraid. So, first of all, this very, very first question here, not something that we've done all together, but something we can have a crack at least, and most people get the idea here that if you look at the example with these sorts of questions, if you look at the example, this 6.7 times 52, and the answer is 348.4, and then in the question, we've got the same digits, so it's a 6 and a 7, and then a 5 and a 2. So all we've got to do then is work out where the decimal point goes. So we know that the answer is going to have 3, 4, 8, 4, those digits in that order, and we just need to work out where the decimal points go. Well, there's several different ways of doing this. The simplest one for me to explain here is probably just have a look at these numbers, 6.7 and 520. Well, 520 is about 500. 6.7 is, well, if we're going to round it to one significant figure, we'd round it up to 10. So 500 times 10 is an answer somewhere in the thousands, 5,000 or so. If you wanted, you could say that's about 500, and 6.7 is about 7, so 500 times about 7, we want the answer 3,500. So let's look at the answer that we've got, 3,484. Well, if I put the decimal point in here, I'd have an answer of 348. If I put an extra 0 on the end, then I'd have an answer of 34,000. So actually, 3,484 is what we're looking for straight away. There's our answer. Part 2, same thing. We know we're going to get these digits 3, 4, 8, 4 in order. Now this is 67 times 0.52, so that's about a half. So about a half of 57. About a half of 67. Well, 67 is about 70. So the answer is going to be about half of 70, and that's about 35. So let's go to our answer. Where do we put the decimal point? Well, put the decimal point here, 3,484. That's definitely too big. If we put it in here, we'd have an answer of 348 and a bit. Well, that's too big. So putting the answer in here, putting the decimal point in here rather, 34.84 is the right size answer to what we're looking for there. The last part, 3,484 divided by 5.2. Well, again, let's do a little bit of rounding. Let's call that 3,500 divided by 5. Now, this is a division, but again, if you notice, 3484 is in the question, and 5 and 2 are in the question. So the answer is going to have a 6 and a 7 in it. And we've just got to work out where the decimal point goes. Well, 3,500 divided by 5, we're going to get an answer there about 700. So we could go for 6.7, we could go for 67, or we could go for 670 or 6,700. But the closest we get to our estimate there is 670. So that's one way of tackling those questions. Question 2, a bit of a tricky one. There are a couple of ways of doing this. But I think we'll go for this method here. Karen got 32 out of 80 in a maths test. She got 38% in an English test. She wants to know, does she get higher in English or maths? Well, one way to do that would be, now this actually isn't the easiest way, but I think it's the way that's closest to the way that most people in our class this year are working with percentages, so I'm going to go for this way. If we work out 38% of 80, we want to know, is 32 more or less than 38%? So if I can work out 38%, then I can say, well, did we get more or less than that? So how do we work out 38%? Well, let's say 10% is 8, 5% then is 4, and I'm going to want I'm going to need to know what 8% is. So in order to do that, we're going to have to do something like, well, let's take 10% and divide it by 5, and that will give us 2%. So 8 divided by 5, well, that's a bit of a tricky one to think about. A couple of different ways of doing this. We could think about it as 8 over 5, and that's how many 5s fit into 8, and work it out from there. So that would be 1 and 3/5, and a fifth, remember, is 0.2, so that would be 1.6. How else could we do it? Well, we could divide by 10 and then double it, so 0.8 times 2 is 1.6, but either way, 2% is 1.6. So 8% is 4 lots of 1.6, and 4 lots of 1.6 were 1.6, and we can times that by 4. A lot of work this early on in the paper, but like I said, not necessarily the easiest way to do this question, but the one which is closest, I think, to the way most people in our class are working. I'll go through a different way of doing it in a moment. 4 times 6 is 24. 4 times 1 is 4, add 2, and then make sure we've got a decimal point in the answer, so 6.4. So 10% is 8, so 30% is 24, so 38% is 30.4. So she got 32 out of 80 in maths, she got 38% in English, so 38% is less than 32 out of 80. So did she get more in maths or English? Well, she got a higher percentage in maths. So that's one way of doing it. Now, there is another way of doing it. Just a minute, let me do it. Let me just try and get rid of all this stuff. There we go. So the other way of doing it would be like this. We'd say in in maths she got 32 out of 80. Well, 32 out of 80, if we cancel that down, is 16 out of 40. That's 8 out of 20, and that's 4 out of 10. Well, 4 out of 10, we can see maybe already that's 40%, but if you wanted, you could cancel that down to 2/5. But the point is, we know that she got 4/10 of the marks here in maths, and that's 40%. So you need to know that 4/10 is the same as 40%, really. So so this other method really is write this as a fraction and then turn that fraction into a percentage. So that's a bit of an easier method, but not necessarily very close to the way most of us like to work with percentages. So quite a hard paper so far on those first two questions. Usually we like the first two questions to be nice and easy. This paper, they've been both quite difficult, but that's fine, because here we are, question 3, and we're back in a completely standard question. Draw a stem and leaf diagram. So without even looking, we know there will be 3 marks here. If we do scan down, look, there is the table ready for us to put our final answer in, and then here in the middle is a nice big blank space for us to do the working out in, and at the bottom, look, there we go, 3 marks. So here we go, let's have a look at our stem and leaf. We have some numbers in the 90s, some numbers in the 80s, some numbers in the hundreds, and some numbers in the 110s, and so on. So I'm going to make my my stems 8, 9, 10, and 11. So 98 would go in there, 90 would go in like this, and remember that first of all, I'm putting these numbers in without bothering to put them in order, and we'll sort out the order in the second diagram. 91. Now I'm doing this very quickly and talking at the same time, so make sure you don't just copy this blindly, make sure you check that I'm putting the numbers in the right places, but go through one at a time. A lot of people, when they're in the exam, don't want to do this method. They want to rush straight to the final answer because they think it'll save time, but if you look at this, that's not taken us very long to do at all, and now we just copy this diagram here, only we put our leaves, that's the things on this side here, in order. So 8, 4, 8, 9, they're already in order. 9, let's have a look, we've got 0 and 0, 0 and 0, 1, 1, let's cross them off if we've done them, 2, 3, 5, 7, 8, there we go, 2, 3, 5, 7, 8. For the stem of 10, we've got 0, 2, 3, 6, 8, 0, 2, 3, 6, 8, and the stem of 11 we've got a 5. So, as usual, we've got 1 mark for this bit up here. We've got 1 mark for putting these leaves in order down here, and our final mark is for remembering to put a key. So key 8 line 4 means 84. Okay, there we go, and there's 3 marks. Now this one is a dotted line question. That means that we may be able to have a go at it. Bit of a tricky one, but let me just show you how to do it quickly. To be honest, I'd be surprised if we got many marks on this one. These are a little bit nasty. So we've got X packs of currant buns and Y boxes of ice buns. There are 6 currant buns in a pack. There are 8 ice buns in a pack. We buy T buns, and we want to write down a formula for T in terms of X and Y. Bit of a nasty question, but this is how to think about it. If we bought 1 pack of currant buns, then we'd have 6 currant buns. If we bought 2 packs, we'd have 12. If we bought 3 packs, we'd have 18. So what we're doing is we're timesing the number of packs, that's these numbers here, timesing that by how many packs we buy. Well, we buy X packs, so that is 6X. With the ice buns, it's the same sort of idea. There's 8 in each box, and we need to know how many we've got in total, and there are Y boxes, so we times it by Y, so 8Y. So 6 times X plus 8 times Y, and that is the total number of buns that we buy. So a bit of a nasty question. Don't worry too much about that one. But again, though, question 5, even though we've had 3 out of 5 questions so far have been nasty, 2 out of 5 have been dead straightforward. So this is something we've seen in lessons, seen several times, so let's have a look. 6x plus 5 is greater than 8, so we solve this like it's an equation, but we make sure that we have this inequality sign in there instead of our equal sign. 6y plus 5 is 8, so something, this something here, plus 5 is 8, so that something there is going to be 3, and then instead of an equal sign, we'll just put that symbol in there. 6 times something is 3. 6 times something is 3. Well, think about that for a moment, because a lot of people here would think about putting 2 as an answer, but 6 times 2 is 12, so that can't be right. So 6 times something is 3. Well, that something is actually going to be 0.5 or a half. And there we go, for 2 marks, there's our final answer. Next, we've got inequalities and number line. Well, remember, whenever you have these, there's one number down here and one number up here, so let's put those down. We've got a 3 and a 4, and it tells us to use the letter X, so we'll use the letter X in the middle. Now, we always need both arrows pointing to the left. So far we're up to 1 mark, and we just need to remember that this dot isn't coloured in, so that symbol there, we leave it like that. This dot here is coloured in, so we make it a less than or equal to sign. So minus 3 is less than, X is less than or equal to 4 is how we'd say that. But the trick we use is write down this number, write down this number, write down the X in the middle, make sure the arrows point in the same direction, which will always be to the left actually in these questions. And then watch out, do you need to put any less than or equal to's in? Okay, Steve wants to put a hedge along one side of his garden. He needs to buy 27 plants for the hedge. Each plant costs £5.54. Steve has £150 to spend on plants for the hedge. Does he have enough money to buy all the plants he needs? So he needs 27 plants, and they cost £5.54 each. So we're going to have to do 27 times £5.54. Oops, excuse me. And then let's read the rest of the question. He has £150. Does he have enough money? Well, with these sorts of questions, usually there's lots of steps, but in this case, all we've got to do is 27 times £5.54 and then see if that's bigger or smaller than 150. Now, it's still worth 4 marks, but the tricky bit here is that we need to find out exactly what this answer is, and it's a non-calculator paper. So all they're really asking us to do is 27 times 5.54 without a calculator. Well, here we go. The way that I would recommend of doing this is this box method. So 5, 5, 4, 2, 7, and then draw the grid out. It would be easier, of course, if you draw your grid nice and neatly with a ruler and so on, but we can get away with this if it's absolutely necessary. we must remember that there's a decimal point here, and I've not got a decimal point in yet on my grid, but we'll put the numbers in anyway. So 4 times 2 is 8, 4 times 7, 28, 7 times 5 is 35, 7 times 5 is 35, and it doesn't matter what order you fill these boxes in as long as you fill them in and you do it carefully. Now then, we need to go down this column here, and we've just got an 8. Coming down this column here, 8 and 2 and 5, that makes 15. So we put the 5 down here, put the 1 across here. 0, 0, 3 and 5 is 8 and 1, that gives us 9. 1 and 3, that gives us 4. And the 1 there goes 14958 for our final answer here. Now, if you've got a different way of doing that, that's fine as long as you get to the same answer. Now, we just need to work out where the decimal point goes. Well, 5.54 and 27, the decimal point would be there after the 7. So one way of doing this is to follow this decimal point down, follow this decimal point across, and then follow the line down. And the decimal point would go here. Another way to do it is just think about it like we did question 1. 5.54 is about 5 or 6, something like that, and 27 is about 30. So the answer is going to be about 150. I can't put the decimal point here to make the answer 1,495. I can't put the decimal point here to make the answer 14.9. So the decimal point is going to have to go here. So the cost is £149.58. The question was, he has £150, is that enough? And the answer would be yes, he has enough. He's got £150. He would have a little bit of change left over. Question 7 is a bit of a mean one. It's not too tricky. It's almost an easy question, but they've turned it around and made it a bit difficult. So I've got dotted lines around this. So might not be one that we can get all the marks on, but we should be able to get somewhere. Now, first of all, we are asked about this shape and we're asked to find the area. So we should be familiar with finding the areas of these shapes by doing something like this. Splitting them up into 2 shapes and working things out from there. So, first of all, we'll have shape A and then we'll have shape B. For shape A, area of shape A is 8 times 15, and that is going to be 120 meters squared. Look in the question there, meters in the question, so it's meters squared for the area. So that there will get us some marks already. Everybody should have some marks for this, maybe 1, maybe 2. Now we're looking for the area of shape B here. Now this is 3 meters, so how long is this length here? Now this is where we start getting a bit tricky, so let's have a think about it like this. The distance I've marked on in red is x. This distance I've marked on in blue is the one that we want to find, and this distance that I'm marking on in black is the same as this 15 up here, so that's 15. So this distance is 15 take away x. So what we've got to do is 3 times 15 take away x, which is, 3 times 15 is 45, 3 times minus x is minus 3x. There we go, let's go back into blue. And we've told that the total area is 138, so what we've got is 120 plus 45 minus 3x equals 138. And we can work from there. So 120 add 45 is 165 minus 3x equals 138. 165 take away something is 138. So 165 take away something, 165 take away. Well, let's you can work that out however you like, but we're going to end up with an answer of 27. 27, do I mean 27? That sounds a bit strange. I think we do mean 27. And then we've got 3 times something is 27, so that something, that x, has got to be 9. There we go. Okay, so a bit of a tricky question, but this part up here that I'm circling in red, we can all get to there, and that should be worth 1 mark, might even be worth 2 marks. So x is 9 there. And if we wanted to show off x as a length, so x would be 9 meters. Okay, number 8, bit of a tricky one. What's nasty about these questions is give reasons for your answer is always difficult. It's worth 4 marks, and usually on a 4-mark question like this, there'll be 2 marks for actually getting the right answer and 2 marks for giving the reasons. So let's see what we can do. We're trying to work out the size of angle x down here. And how can we do that? Well, first of all, I'd say that this angle here is 65, and as I've said in other videos, this is not necessarily the proper way of doing this, but the easiest way of making clear what you're looking for, that these are alternate angles. So those two are the same because they're alternate angles. Now this thing here is an isosceles triangle because we have these 2 little marks to tell us these sides are the same length. So that means that this angle here is also 65 degrees because this is an isosceles triangle. So that would make this one here, well, those 65 add 65 is 130, so that makes this one here 50 degrees because angles in a triangle add to 180 degrees, which would make x 130 degrees because angles on a straight line, oh, I can't fit it in here, but there we go, angles on a straight line add up to 180 degrees. And apologies again for the slightly wobbly writing on this iPad. Question 9, very familiar territory here. Jack wants to find out how far people live from their nearest supermarket. He uses this question, right? And 2 things wrong with this question. Well, what's tricky with this one is we can't say the usual thing, which is the time frame. We don't need a time frame. We're not asking people how often they do something or how much or how many times they go shopping in a week or something. So we don't need a time frame. But we can still say the response boxes overlap. So if you wanted to tick 2, then you'd have to tick 0 to 2 and 2 to 3. So excuse me. So first reason the response boxes overlap. Now the second thing, just read the question and see what's wrong with this. How far do you live from your supermarket? 0 to 2, 2 to 3, 3 to 4. Well, 0 to 2 what? Is that miles? Is it kilometres? Is it meters? So there's no units in this question. It doesn't tell us any units. So there's an answer there. So bit of a nasty one. Usually we can always just get away with a normal answer, no time frame, and the response boxes overlap. But maybe they're getting the exam board are used to the fact that we always know those are the answers, so they've changed the questions occasionally. Now, read this one very carefully as well. We don't want to do a better version of the question above. We want to say, how often do we go shopping? So we need a question which says something like, how many times would you go shopping in a week or in a month? Something like that. Make sure you've got a time frame in the question. And then your response boxes need to be exhaustive and non-overlapping. So exhaustive meaning everything's covered, and non-overlapping means they don't overlap. So the easiest way to do this would be, how many times do you go shopping in a week? 4 to 6, less than 4, and then more than 6, something like that. Let me just check that we're happy with these response boxes one last time, because what a lot of people are doing is something like saying less than 3 and then 4 to 6. Well, less than 3, what if you wanted to say somewhere between 3 and 4? Now, if we're saying how many times do you go shopping, that would be okay. You can't go shopping 3.5 times. But if this was something where we're asking kind of how far you go to the nearest supermarket, then you could go between 3 and 4 miles. So if we say less than 4, we don't have that problem. Now, some people get worried about the 4 being here and here, but if we think about it, less than 4 doesn't include 4. So if you wanted to tick 4, then you'd have to tick the middle box, because 4 to 6 includes 4, less than 4 doesn't include 4, less than 4 means less than 4 but not including 4. So less than 4, 4 to 6, more than 6. You don't have to use the numbers 4 and 6, but I usually do in most of these questions, and we get away with it. This is one which you may have done at some point this year. We set it as an additional homework, and if you know how to do that, then have a go at that one. Number 11, we're going to buy a caravan. The total cost is £7,000 plus VAT at 20%. We pay a deposit of £3,000 and the rest in 6 equal monthly payment. Work out the amount that we pay each month. Well, one way of there's a few different ways through this, but I think we'll go this way. £7,000 plus VAT at 20%. Well, that we need to know then 20% of 7,000. So 10% of, oh dear, let's get rid of that. That's me nudging the iPad. Here we go. So 10% of 7,000 is 700. 20% of 7,000 is 1,400. So the total to pay is 7,000 plus 1,400, which is 8,400. Okay, now we pay a deposit of £3,000. So after deposit, we have 8,400, take away £3,000, so that's £5,400 to pay. And that gets done in 6 payments, so we need to do 5,400 divided by 6. Well, we know 54 divided by 6 is 9, so this is going to be 900 per month. There we go. First part of this one, a factorising question. We need to look in here and find out what's the biggest number we can take out from both of these. Well, there's no number that fits into 3 and 5 that's useful, so we'll leave the numbers as they are, but we can take an e out from the first one and we can take an e out from the second one. So that's going to leave us with 3e and 5. Remember, we leave an e in here because we've got e squared there. Not everybody's happy with the factorising, so I've put a dotted line around that. Not all of us will get that mark. Next one, everybody should at least get 1 mark here. As soon as you see an equation with some brackets in it, you know you've got to expand those brackets. So 7 times k is 7k. 7 times minus 3 is minus 21. And that equals 3k minus 5. Now, we're going to get these 3k and we're going to flip them over to this side of the sign of the equal sign, but remember we change them into a negative 3k. So 7k minus 3k is a 4k on this side. And that leaves us with this. And now we go for our sort of cover it up and think about it kind of method. So put our finger over this 4k, something take away 21 is minus 5. So if we've taken away 21 and we've ended up down at minus 5, where did we start off? Well, we could think about that as minus 5 and then plus 21 if we like. So we're going to get, I think, 16 is 4k. So something take away 21 is minus 5. That something must have been 16. So 4k is 16. And if 4k is 16, then 1k is going to be 4. Now we have done this next bit, but in fact I'll just clear a bit of space, I think. Let's just delete that so we've got some space. We have done this next bit, not something that everybody finds easy, but we can get the marks if we're careful. So 2x times x is 2 times x, so that's 2x squared. 2x times minus 8 is minus 16x. 3 times x is 3x. 3 times minus 8 is minus 24, and then remember these x's in the middle, we can collect those together, so we get 2x minus 13x minus 24. Part D, really, I'd be surprised if we managed to get marks on this, but we might just be able to, because this is something divided by 4 is 2. So something divided by 4 is 2. That something must have been 8. So that something is 7 minus 3f is 8. And if we work from there, then we will get to the answer. So 7 take away something is 8. Now, bit of a tricky question. That 7 take away something is 8. Well, if you think about it, that means that something, that 3f, has got to be -1. If you do 7 take away -1, you get to 8. So that means f is -1 divided by 3, and that's just -1/3. Horrible question, but technically we can do it with the skills that we've got. Number 13, express 180 as a product of its prime factor. So this is 3 marks for a question. If you can remember what we did in the lessons, we're laughing here. So that's 2 lots of 90. 2 is a prime number, put a circle around it. 90 is 9 times 10. Neither of those are prime numbers, so we don't put a circle around them. 9 is 3 times 3. Circle around those. And 10 is 2 times 5. They're both prime numbers, so put a circle around them. You might have used different numbers. So you might have said 180 is 3 times 60 to start with, or you might have said at this stage here, you might have said 90 is 45 times 2. It doesn't matter which way you go, but you end up with the same numbers at the bottom. And it says write it as a product of its prime factor. So product, remember, means timesing numbers together. So we need 2 times 2 times 3 times 3 times 5. And if we're feeling swish, we do 2 squared times 3 squared times 5. Make sure you write this line down, because you'll get full marks on this question, you'll get full marks for this line. On another question, it might say write it as a product of its prime factors in index form, in which case you'd need this line. But if you try this line here and you get it wrong, then you'll get full credit for this line. So watch out, make sure you've done that one. Now part B, bit of a horrible question this, but again it's something that we can do. So we're thinking of 2 numbers. The highest common factor of the 2 numbers is 6. And the lowest common multiple of the 2 numbers is a multiple of 15. So let's break that down. The highest common factor of the 2 numbers is 6. So that means we're thinking of 2 numbers that are in the 6 times table, because they've both got 6 as a factor. So that's one thing we can do to start with, is look at the 6 times table. And the lowest common multiple is a multiple of 15. So that means they both fit into a number which is in the 15 times table. So let's have a look. Let's have a look at the 6 times table. 6, 12... and so on. We don't know how far we've got to go, but let's just go this far to start with. Now, highest common factor of 2 numbers is 6. So if we pick any 2 numbers out of this list, if we pick 12 and 24, for example, the highest common factor of those 2 is not 6 anymore. The highest common factor of those 2 is 12, so that wouldn't do. But if we try and pick different pairs and see if we can find a pair that work, well, let's say we pick 6 and 12. Well, the highest common factor of those 2 is 6, so that's the first condition ticked. But then the lowest common multiple is a multiple of 15. Well, the lowest common multiple is 6 and 12. Well, 6 fits into 12, and that's not a multiple of 15, so that's no good. But that maybe gives us a clue as to how we could do this. 6 fits into everything in this list. So if I can find another number which is a multiple of 15, then we should be able to do that, because that should fit both of these conditions. So 30 is the first thing that's a multiple of 15. So let's have a look at 6 and 30. Well, the highest common factor then has got to be 6, because 6 fits into 6, 6 fits into 30. We can't have anything bigger that fits into 6 and 30 because it won't fit into 6, so that's good. We need the lowest common multiple is a multiple of 15. Well, 30 is a multiple of 15. The lowest common multiple of 6 and 30 is 30. So 6 and 30, as I said at the start, something that we can technically do, but quite a hard version of that question. But we can technically do it. Okay, this question. We have 600 millilitres of wallpaper remover, and we're going to mix some of this remover with water. Here is the information. We've got, on the bottle it says, we've got 600 millilitres in total. We want a quarter of that with 4,500 millilitres of water. We're going to use 750 millilitres of water, so how much wallpaper remover should we use? So this is just one of those recipe questions. Normally these recipe questions, we're making scones or cakes or something like that. In this question though, it's wallpaper remover, but we use exactly the same maths. So a quarter of the wallpaper remover with 4,500 millilitres of water. Well, a quarter of 600 would be 150. If you're not sure, remember a quarter is half it and half it again. So 150 millilitres of wallpaper remover goes with 4,500 millilitres of water, and we're going to use 750 millilitres of water. So 4,500, how do we turn that into 750 millilitres? Just by timesing and dividing. Well, there's several routes through this, and it depends on if you think of a nifty one, how difficult the maths is going to be. But one way of doing this, let's see, if we divide by 100, then we'd get let's divide by 10 and we'll get 450. And then if we divide by 9, we will get 50. And then 50, we know, fits into 750, and it's going to be times 15, isn't it? Okay, so divide by 10, divide by 9, times by 15. There are quick ways there. There are shorter ways there. You might spot that if you divide by 6, that will get us all the way there. But I'm guessing that's a tricky thing to spot. So 700, if we just check it, 750 times by 6, or 750 times by 2 is 1,500. And then if you times that by another 3, you get 4,500. So you might spot that one, but it's unlikely. So here's a more likely route. Divide by 10, divide by 9, times by 15, because we are on a non-calculator paper after all. So 150 divided by 10 is 15. And then we've got to divide by 9 and then times by 15. Divide by 9 times by 15. Now this is the tricky bit, 15 divided by 9. Well, we could do that like this, 15 divided by 9. Or we could do it like this. How many 9s fit into 15? Which is the easiest of these? I think we'll go for just going this way. So how many 9s fit into 15 is 1 and 6 left over. How many 9s fit into 60? Well, that is 6 and 6 left over. How many 9s fit into 60? That's 6 and 6. So 1.66666 times by 15. Or in other words, 1 and 2/3 times by 16. So 1 and 2/3. And then we've got to times that by 15. Well, 1 times 15 is 15. 2/3 times 15 is 10. So we're going to get an answer of 25 millilitres. If we had a calculator, that would be a nice easy question. Without a calculator, there's some nasty numbers to try and deal with there. Okay, we have a box plot to draw here. So the students in the class kept a record of the amount of time in minutes they spent doing homework. This table shows the information of the amount of time the girls spent doing homework last week. So we want the least amount of time. Let's have a look. We go from 50 here up to 100, and there's 10 little squares in the middle. So each little square must be worth 5. So 60 is 2 little squares past 50. So there's 60 there. The range is 230. So we're going to need to. So from the smallest to the biggest is a gap of 230. So that's going to mean that our biggest piece of data is 290, which is going to be well up here. The median is 170, so we're going to go there. We've done that one. Lower quartile is 100, nice and easy that one, and 220 for the upper quartile, so that's going to be here. And then we make a box plot sort of shape out of those numbers. And then the box plot below shows the amount of time boys spent doing homework last week. Compare the amount of times girls spent doing homework with the amount of time the boys spent doing homework. Well, with these questions, if you remember, what we've always got to do is we've got to compare the range and then the interquartile range and the median. And we will say which is bigger for each of them. So you'll have a bit more space than I have on this little screen here. So the range, well, for boys it's from 60 to, well, we in fact it gave us in the table as 230. So for boys, girls, it's 230. The range for the girls goes from 250 down to 40, so that's 210. The median is the next easy one to do, so that's 70 here, and for the boys it's 190. 170 and 190, 170 Oops, wrong way around. For the girls it's 170, for the boys it's 190. And then the interquartile range, remember, is the built up quartile, take away the lowest quartile, and we could put those in there as well. And then you just need to say which is bigger and which that means. So, for example, on average, the boys spend more time doing homework. That would get you the second mark there. So the first mark is for making two comparisons. So this, as long as we said here we said the range is bigger for the boys, and here we said the median is bigger for the boys, then we get 1 mark out of 2 for those two things. The second mark comes from putting one of those remarks in context. So saying the median is bigger for the boys, this means on average the boys do more homework. That would get us the mark there. Number 16, we're first of all drawing a cumulative frequency graph, and then the second part, and we'll just remember this because we'll look at it on the next slide. 10% of the workers are older than 65. Is he correct? Well, let's have a look. If you remember with the cumulative frequency graph, what we've got to draw is that they've already done the cumulative frequency column for us. So they've done the first bit. So we just take these numbers and plot them on the graph. So I've copied that table out already onto this slide. So we're going to plot 20 against 25, 30 against 70, and so on. So, in fact, I'll tell you what, we'll do it like this so we can see it all on one screen. An age of 20 and a cumulative frequency of 25. So 20 and 25, pretty straightforward sort of stuff. 30 and 70, we just got to plot these. 40 and 138. Make sure, again, you've got to look at your scale. From 130 to 140 is 5 little squares, so each little square is worth 2. Now, I can't plot this as accurately on this iPad as you could with a pencil on your exam paper. So make sure you are exact to within the nearest half a little square. So 50 and 175. I'm being very scruffy there. There we go. Let's try and get it a little bit neater. 160 and 186. 70 and 194, and 80 and 200. Oops, there we go. Now, what we're also going to remember is a cumulative frequency curve. We join it up with one smooth curve that goes through all the points, like that. Now, it's a bit scruffy, but we're getting the right idea. Now, the question was... this is part B, sorry. The question was, are there 10% over 65? Well, so that means we're going to go to 65. We'll draw a line up from 65, and obviously you'll use a ruler, and then we'll draw a line across. And I'm getting an answer of something like 190. So the cumulative frequency is 190, so that means there are 190 people who have an age up to 65. So that means there are 10 people, so if you look, the highest point on the graph is 200, so there's 10 people who have an age older than 65. So is it right that 10% of people have an age older than 65? Well, that's 10 people out of 200, so that's actually only 5%. So the answer there would be no, it's only 5%. Okay, we're getting towards the things which we're not going to have a look at now. So 17, 18, going to miss these ones out. 19, though, even though it's quite late in the paper, this is something that we can do. Remember, all we've got to do is take the numbers here and substitute them into this thing. So this is 4 divided by the x value. So 4 divided by 0.5 is going to be 8. 4 divided by, so 4 divided by the x value, 4 divided by 4 is going to be 1. 4 divided by 5 is 0.8 or 4/5. And 4 divided by 8 is a half or 0.5, and then we've just got to put those points into our table. So let's shrink this down again a little bit. So x is 0.5, y is 8. So x is 0.5, y is 8. Oops. There we go on the graph. 1 against 4. Let's plot 2 against 2, and we're just putting all these points in, and then 4 across and 1 up. 5 and 0.8. Oops, there we go. And 8 and 0.5. And then we get one smooth curve through all the points with a nice sharp pencil, and that's what we've got there for 4 whole marks. And we're very nearly finished. By this point in the paper, we've normally finished questions that we can do, but one more bonus mark for us, and that's this one here. something to the power of 0, the answer is always 1. So it doesn't matter that it's a 3e in brackets, it's a power of 0, so our answer is 1, and that is the end of that paper.